Hey guys, and welcome back to a new project video. This video will probably be one of the most important videos you can watch as an Android developer if you actually want to succeed in your career. Because it will be about making a clean architecture MVVM app with use cases, that whole clean architecture approach. And I will just show you all of that in this video. I will explain the structure of the project, I will explain use cases, I will explain everything that belongs to it. And this is so important to know as an Android developer, because if you don't know how to structure your applications, then that means you can't build any apps that go beyond like 2,000 or 3,000 lines of code, and pretty much every app goes beyond that. Therefore, please don't skip this video. Get yourself a cup of coffee, enjoy it, but take yourself that time and learn. It's free. I decided to not make this a paid video. This could easily be a course for like 50 or 100 euros, but I give it you for free because I think this is something every Android developer should know, and therefore I decided to put it on YouTube. Are there any prerequisites here before you can start with that? Well, yeah, you should be somehow familiar with Android. You should know like basics of dependency injection with Dagger Hilt. You should know retrofit, making network requests, and the basics of Jetpack Compose. So we will be using Jetpack Compose here. And what we will build is, we will build a cryptocurrency app. So this app will just display pretty much all cryptocurrencies here that there are. Those come from an API. And if we click on one currency like Bitcoin, we will get this detail view. We have another API request. We get a description, some tags that belong to that currency, and the members who actually founded that currency. And all that will be done with the MVVM clean architecture approach, like from Uncle Bob, in case you don't know that. It's basically Uncle Bob who came up with this approach, which just extends the typical architecture that I use in my project, which is just plain MVVM, with some more things that help you to make your app more testable, more extendable, better understandable, especially that. Yeah, just make sure that your app scales. That is the goal here. So I will explain everything we do, but those things that don't directly have something to do with clean architecture, I will go through them quicker, and I will actually focus on explaining the structure of the project. I will focus on explaining use cases. I will focus on explaining, for example, why we use dependency injection and just how that helps us with a good architecture actually. So enough talking, let's actually jump right into it. And you actually need to get the initial project here. It doesn't contain a lot, just the typical stuff. So it's an empty Compose project, as you can see. All that I really have included is a theme. So we don't need to worry about colors and, for example, text styles here. You can include that. I mean, you can just go to the link down below that says initial project. You will then see this page, that is the GitHub repository here. You want to be sure that you're on the master branch, which is the initial project. You can click on code, copy this URL, go back to Android Studio, file new project from version control. That is what you want to do. And here you can simply paste that URL, click on clone, and Android Studio will include my project in your Android Studio. That is just the easiest way to include that. You can also just go to download zip and import it like that, but I prefer using Git for that. If you struggle somewhere in this course and you want to see what my code actually does, you can also visit this repository, click on master, and then there will be an app branch. So that app branch will contain the source code, so the final source code of this project. So when that is done, next up I want to show you the API that we use. And that will be Coin Paprika. That is a free API. It doesn't require any kind of authentication, so we can just access it without any further setup. So it's basically just an API for cryptocurrencies, exactly what we want. Then we have two API requests here that we will need in our project, which is on the one hand this API coinpaprika.com/v1/coins, which gives us the list of all coins that are out there or that are in that API. And that is a lot. This is like a 700 kilobyte JSON response that we will get in our app. And you will find all these links, by the way, down here in this description. So this API link, you will find the other API link here. So for a specific coin, to get the details, we get this, for example, for Bitcoin. And that is actually it. One last thing before we actually get started is, if you like these clean architecture concepts and you want to learn more of these for free, then you can check this video's description, because I now have an email newsletter and I will send you regular advice on Android development, on Kotlin, on getting a better developer, and I will especially focus on more advanced concepts there, like this one here, clean architecture, and just specific things. Because right now I have Instagram posts, I have YouTube videos, which is all visual and auditive content, but you might also like to see some written content by me, and that is what this newsletter is for. So go down below, and there you can subscribe to this newsletter, and then you will receive regular Android advice right into your inbox. But that is now really it. Let's go to Android Studio and jump right into it. So what the heck is actually clean architecture? For a while I thought that it's just MVVM in Android. MVVM is an architectural design pattern that helps us to structure our code and scale our projects. However, clean architecture kind of extends this. It actually includes an additional layer in MVVM. So in MVVM we have model, view, and ViewModel. And in clean architecture we have one more layer, which are use cases. And these use cases contain our business logic. So in MVVM we just put all of our business logic into our ViewModels. And the problem with that is that the bigger your project gets, then you start to have these typical God ViewModels. A ViewModel that just does everything. And this is one thing this clean architecture approach tries to avoid, and actually does that quite successfully, because we now use these so-called use cases. So what is a use case? A use case is basically kind of a part of a feature of your app. So let's first understand what is a feature. A feature is just a set of screens together that are somehow related. So for example, the profile feature. That could be you have a profile screen and you have an edit profile screen. And these two screens together make up a single feature. The use cases would now be single actions we could do in these features. For example, get user profile data, update user profile picture. All these would be use cases, so single actions we can do within a single feature. The big advantage with use cases is that they, on the one hand, are very reusable. So if we have an additional layer, which are the use cases here, then we can reuse that. So for example, if we have a use case, get profile data, and we need that on multiple places in our application in different view models. If we wouldn't have that in a use case and would put the logic for that in the view model itself, then if we have two view models that need to access the same data, we would have the same code in two view models. If we have one use case class in which we put that code, then we can simply use that use case class and use it in both of our view models. So it removes code duplication. And advantage number two is that it leads to what a blog article actually called screaming architecture, and I like that term. Screaming architecture is basically that you take a look at your classes, at your project hierarchy, and it really helps you to understand what the project is about. Because, well, what you will see is you will have a package for use cases in that you will have, for example, a feature profile, and that contains get profile data use case, get profile, or rather update profile picture use case, whatever, delete profile use case. And you don't even need to open that class. You know what's in there. You know that it's used to update a profile. You know that it's used to update a profile picture. So that is what we mean with a screaming architecture. It screams at you, hey, this is what I'm for. So far so good about use cases. There's something else you need to know before we can actually jump into practice here. And that is that we basically now separate our project into three layers. On the one hand, we have presentation. So the name kind of says it, it's used for UI. So we present something to the user. So in the presentation layer, we put all of our composables. If you use XML, for example, your views, your view models actually also belong in there. Then we have a domain layer. The domain layer contains our models, so the actual entities that contain data. It contains repository definitions, for example, so the interfaces for repositories. And it contains our business logic, so our use cases. And finally, we then have the data layer that, well, the name says it, it contains our data. So it contains our API interface, a database if we have one. We don't have one here, but if we had one, it would be in there. It contains repository implementations, for example, and all that stuff. I will actually jump into it now because it will get clearer when we implement that. So what I will do first here is I will set up our package structure because it will be quite huge, and it seems like it's a bit overkill here for this project, and it actually is, because it's a very small project we have here, and we use an architecture that is made for apps that should scale. But to make you understand how it works, I will use the same package structure as I would use in a big app. So as I said, we have 3 layers in our app. Let's create a package in our root package. For presentation, so our UI package basically, and we can take our UI package here and main activity, move it inside of that presentation package. Then that's a little bit buggy here. It will disappear soon when we create another one. Let's go to our root package, create another package for domain, and one more for data. So these are the 3 layers we now have in our app that will lead to a separation of concerns. So that helps us to just test these layers in isolation and that they don't really affect each other. So if a test case actually detects that business logic fails, then we want to be sure that the issue is also in the business logic layer, so in the domain layer. What shouldn't happen is that if we test our app, let's say we test a use case and the test case fails because of some error in our data layer. That shouldn't happen. And the separation of concerns helps with that. I will create one more package in our root package, which is called common. And well, we will put everything in there that all of our other 3 layers have in common. So for example, a file for constants, let's create that. Constants here, which is an object. Yes, let's add that. And I will also paste one more file, which I use in all of my project playlists. So I won't write that from scratch here, but I will explain you what that is for. It's called a resource file. It's basically just a generic wrapper class. If you've never seen this looks super complicated, but it actually isn't. So we just can put this class around any type of object, which will in the end be our network response. And this wrapper class just contains information about the actual data and a potential error message. So if something went wrong, we can just emit such an error. We can emit success if it was successful, and loading when we're actually loading. So that will just help us for our UI state later on. If you don't know that, you will understand that later. Then let's further build our package structure. Starting in our presentation layer, I like to have a package here on the one hand for coin list, so the main screen. For every single screen I will now have another package. And we have one for coin detail. So that is the detail screen. And usually you would also use a multi-module architecture here, that you structure your project with multiple modules, but that would definitely be too much for a single YouTube video. So I will use this approach here in just having 3 different packages. And that is also the easiest approach. Then in these 2 packages, I will create another package, which is called components. So that will just contain composables that we need inside of that package here as well. Okay, but that is it for the presentation package structure. Let's hit further to the domain package structure. This will contain a package for models, so a model package. It will contain a package for repositories, so repository package, and finally one for use cases, so a use case package. In that use case package, we will have our 2 use cases in this app. On the one hand, to get coins, and on the other hand, to get a single coin, so to get the coin details. These are the 2 major use cases we have here, but they don't need to be related to getting data. A use case can also be something like searching in a list, for example. But usually it involves some kind of database or API, but it doesn't need to be. So let's create our two packages here, get coins plural and get coin singular. So those are the two use cases we have. That is for a specific coin and that is for all coins in the list. Then let's go on with our data package. That will also contain a package for repositories. And the differences between these two, we will explain that when we get to that point. We have another package for remote, for our remote data source. And that will have a package called DTO. So what does DTO stand for? That stands for Data Transfer Object. And it's basically the object that our API returns. But very often we don't need all the data that our API returns. So we actually want to have LiDAR models that only contain the data that we actually show in our UI. These LiDAR models come into our domain model package, and the DTOs that come directly from our API come inside of the data package. And that is also already it for the data package. One very last package we need is in our root package, a DI package for dependency injection. And that is now really it for the package structure. So that is how I would approach such a project and how I would structure it. And also if you choose a multi-module approach, then you will find this type of structure here over and over again. So you always need to know the differences between data, domain, and presentation, and what are use cases and all of that stuff. That will be the same in multi-module projects. So let's get to the actual coding part finally. I want to start with implementing our API. So I will structure this kind of from the top to the bottom. So we will implement the UI the last, because I think the rest is more interesting here, and that is also why you watch this. So let's start with the API, then we'll implement repositories, use cases, view models, and stuff like that. So we already have the data when we implement our UI to display that in our UI. So in remote, we create a new Kotlin class or file, which will be an interface. That will be our retrofit API interface called Paprika API. If you're new to retrofit, in this interface you basically just define the different functions and routes we want to access from our API. So we will have two functions here. On the one hand, to get coins, get all coins, and on the other hand, to get details about a specific coin given that coin's ID. So what do we have here? We have two GET requests. We want to get data. We don't want to post anything. So we annotate this with @get, and the route to that will be /v1/coins. So that is everything that comes after the base URL. That will be a suspend function, so we execute it in a coroutine asynchronously, and it's called getCoins. We don't need any parameters here, we just want to get all coins. And well, what will this now actually return? It will obviously return a list of coins, but we don't have the objects for that yet. And for that, let's head back to Google Chrome, to the page I actually showed you where you can access the API. This one here, this /coins, that gives us the list of coins in form of a JSON file. And we now need a data class that represents such a coin. So we simply want to copy one of these, go back to Android Studio, go to DTO, because that is now a data transfer object, right click, and we say Kotlin data class file from JSON. If you don't have that, that comes from a plugin, you need to install that. You press Ctrl, Alt, and S, so your settings open. You go to Plugins, Marketplace, and you search for Kotlin to JSON class here. This is the plugin you want. Restart Android Studio, and then this option will appear for you. So right-click, DTO, new Kotlin data class file from JSON. Here you paste the JSON text, and we need to give it a class name, so how this data class should be called, and I will call it coin DTO. And then we can click generate. And if you now take a look in coin DTO, that is what was generated. So it automatically also attached serialized name here. So that is the name it has in the API, and that is the name that we should use because it's a naming convention to name variables like that and not like that. So that is now what is called a DTO. This is the object that we get from our API. However, in our app, we don't want to display all that data here. For example, we're not interested in is new. We don't care about that. We're not interested in the type. So we should rather use an object that doesn't contain these types of things. And that is what I will do. I will go to model now in domain. So that will contain the data we actually access in, we actually display in our UI. Create a new Kotlin data class, and I will just call this coin now. And this coin will contain everything of this coin DTO except for the type and is new. And we can also remove the serialized name annotations. So this is the data class that we will just use to display specific coin data in our list. Now we get this from our API, but we want to use this in our code, in our UI. So we need a way to kind of map these. We need a way to transform a coin DTO to a coin object. And that is what we usually do when we have coin DTOs, that we write a function that kind of maps that. So function coin DTO dot to coin, that will return a normal coin here. And we just say return a coin here from our model package, and we just assign the data as we want it to have. It's basically the same data, just without some extra entries. Is active is active, name is name, rank is rank, and symbol is symbol. And then we can later easily call this function to convert a coin DTO to a normal coin. Let's get back to our coin Paprika API interface. And this function now returns a list of these coin DTOs. And then the rest and the parsing will automatically be done by a JSON. So let's implement the other function we have here, which is also a get request, and that gets data of a specific coin. So also /v1 /coins, and that now takes the coin ID in the URL as a path parameter. So we need to write it like that. So retrofit will replace that later. Suspend function get coin by ID. Here we have that path parameter. You need to give it the same name as we have up there. And we call the variable coin ID as well, which is a string. And well, what will this return? We don't have that yet. So we need to do the same process again. We need to go to Chrome, this time the second API request, for example this one here that gives us details about Bitcoin. Hit Ctrl A to select everything, copy that, go to Android Studio, go to DTO again, right click new Kotlin data class file from JSON, paste the stuff in here, and now that will be the coin detail DTO. So that just contains data and details about one specific coin, like Bitcoin for example. And we click generate, and that will generate a lot more classes, as you can see here. And that is really the cool thing about this plugin. So we don't really need to do anything. But what we need to do is we again need kind of a class that we represent in our UI. So we don't want to pass such a coin detail DTO, which is a huge class here. We don't want to pass that to our composables to display that. It contains a lot more data that we would like to have. So let's actually fix that. First of all, one thing, you will notice that down here it has a list of teams, and we display that in our app. So that is this team members list here. I like to rename that because it's actually not a list of teams, it's a list of team members. So this list of team members makes up a team, so that's fine, but this one isn't fine. So let's simply press Shift F6 here and rename this to team member. And we don't want to rename this, so don't check this box, click OK, and there we go. So now we create a model class for that represents the data we display in our UI in our model package here. So new Kotlin data class called coin detail. And well, what will this contain? It will contain the coin ID, we need that. It will contain the name of the coin. It will contain the description, the symbol. It will contain the rank, which is an integer this time. It will contain if the coin is active or not, so Boolean. It will contain the tags that we want to display here in our coin detail, so these tags here, which is a list of strings. And it will contain the team, which is a list of team member. So that is all the data we need in our detail screen here. So what we now do is we go back to coin detail DTO, and if you watch this carefully, you know what we're going to do now. We'll write a function to convert such a coin detail DTO object to such a coin detail object. So let's scroll down. Function coin detail DTO that to coin detail returns a coin detail, and here we say return coin detail. Coin ID is equal to, I think it's just ID. Name is equal to name. Description equal to description. Symbol is equal to symbol. Rank is rank. Is active is active. The tags are equal to the tags, but this is a list of tags and not of strings. So we're only interested in the tags as a string, so we can say that map, and we map that just to it.name. So the name of the tag is the actual string. And we have the team, which is just the team here. Okay, cool. So we have our mapper function for that as well. So we can hit back to coin Paprika API and make sure we have the right return type here, which is just our coin detail DTO here. Then we can now go to our domain package in the repository package, because next I want to create our repository. And now you might have already wondered why we have a repository package in our business model domain layer and why we have that in our data layer. What's the difference? The difference is that in our domain layer we kind of only define our repositories. So we create an interface here. Let's do that. New interface called, let's say, coin repository. And in here we define the functions this coin repository should have. So that should of course just have one function for each API request we have. If you would, for example, add some caching, then this would also have functions to insert in a database and stuff like that. We don't have that, so we only have that for the API functionality. Suspend function get coins, and that returns a list of coin DTO objects. And another suspend function to get a coin by its ID with the coin ID, which is a string, and that returns a coin detail DTO. So these are the two functions we actually have. Let's go to our other repository package now, and in the data package, the repository package now contains the implementation of our repository, because the actual implementation also contains the direct access to our data. Just this interface definition we have here hasn't much to do with getting something from an API, getting something from a database, because we just say, hey, these are the functions we have. And the reason why we have an interface here at all is that is very helpful for test cases. Let's say you actually want to test a use case later that uses this repository. Then you don't want to run this test case for the use case with your actual repository implementation that uses the API, because that would just take way too long. You use your API quota, maybe your Firebase quota, whatever you use. You of course don't want that in a test case. It takes a lot of time. Instead, what you do for tests is you create fake versions of these repositories. So you just have a fake repository that simulates the behavior of an API in this case. And then this fake repository can also implement this coin repository interface. So in the end, our use case doesn't care what kind of repository it gets. It just knows, okay, whatever I get, it will have these two functions. And that's all the use case really needs to know. So let's go to our repository package in the data package, create a coin repository implementation here. And that will now have an inject constructor. So we inject dependencies here, which is simply our API instance. So our Paprika API actually. This will now implement the coin repository, of course. We can press Ctrl-I, implement those two functions. And here we can simply now return API.getCoins and API return API get coin by ID, and we pass the coin ID. That is already everything for the repository. Looks like a lot of boilerplate code here, and here it is actually boilerplate code, but the bigger your project gets, the more helpful these repositories will be, especially if you also have a database and you have some logic in there, then these really make sense. And I want to show you how I would actually structure a bigger app here. So now we have our coin repository implementation. What comes next? Next, let's implement our actual use cases. And these use cases will use that repository to access our API and basically forward that information to the ViewModels. So let's go to domain, use case, and let's start with get coins. So we create a new Kotlin class called get coins use case. That is kind of what I always call my use cases. So first, whatever they do, and then just use case. So we just need to look at it and know, oh, that's a use case. Press enter. We inject our repository here. So private val repository of type coin repository, and take care that you now don't inject the coin repository implementation. You want to inject the interface because that allows it to be easily replaceable. And now one thing I like to do for use cases is to override the invoke operator function. So first of all, a use case should only have one public function. And that is the function to execute that use case. In this case, to get the coins. In the other case, to get the coin details, to perform the search, to update the user profile. There's always one major feature that you expose to the ViewModels that a use case should contain. So even though we could, we shouldn't put both our logics here inside of this single use case. So to get coin details and to get all coins. That is bad, because then the purpose of a use case isn't fulfilled anymore. So what I will do is, I will have a function, actually an operator function invoke, and this won't take any parameters, but it will give us a flow from coroutines of type resource, of type list, of type coin. And that looks very complex now. It actually isn't so complex. So let's declutter this. We override the operator function invoke. This is optional. Some people like to call it, I don't know, execute or so. But with this, if we override the invoke function, we can basically call this use case as if it was a function. And I like it. Then we return a flow because we want to emit multiple values over a period of time. So first we want to emit that we are actually now loading use cases, so we can display the progress bar. We want to emit if it's successful, and we want to attach our data, our list of coins. And if an error happens, we want to emit an error here. And that is what this resource will be helpful for. So here we can emit success error loading one step at a time in our use case. And the data that we would emit, if we have data, would be of type list of coins. So if it was successful, we just attach a list of coins. That's the whole magic here. So we can say that's equal to a flow. We want to put that in try and catch. So in case something goes wrong, we want to, on the one hand, catch HTTP exceptions, which will happen if we get a if we get a response code, an HTTP response code that doesn't start with a 2. So that usually means it was not successful. And we want to catch IO exceptions. this one. This happens if our repository or our API can't even really talk to our to the actual remote API. For example, if no internet connection or whatever. So here in the try block, the first thing we want to do is we want to emit loading status, because when we call this invoke function, that means, hey, we want to execute that use case now. We want to get the coins. And the first thing that should happen is we display our progress bar. So we say emit resource.loading, and that doesn't need any parameters. So we will then receive that in our view model and then in our UI, and we can display the progress bar. We will then have our list of coins that we get from our repository. Get coins. And remember, that is now a list of coin DTOs. We return a list of coins, so of the object we actually display in our UI. So if that line did crash, we know it was successful, so we can say emit resource.success. And here we now need to attach the data that we want to forward to our view model that contains the use case. So this data will be our coins, but as you can see, we get an error because we pass a list of coin DTOs and it expects a list of coins. So what we want to do is we want to call map. So we map all single coins in that coin DTO list to a coin, and then the error is gone. Then in here, in the catch block, we want to emit an error, obviously, resource.error, and the message for that error will be e.localized message, and if that returns a null, we can say an unexpected error occurred. So that will just attach the exception message or the error code, and if that doesn't exist, we just display this. And if an IO exception happened, we say resource.error. That usually means that there was no internet connection. It could also mean that the server is offline, but usually it means there is no internet connection. So we just say couldn't reach server, check your internet connection. And that is it for our use case. So now we can reuse that wherever we like in all of our view models that need to get coins, and we don't need to rewrite this logic all the time. And if now, let's say we work in a team and we get a new team member, then all the team member needs to do is take a look in the use case package, see, oh, get coins use case. And the team member will automatically know the logic that is in here will just deal with getting coins. It's just a very clear naming and very clear structure to understand this project. So I will now actually copy this use case, paste it in our get coin use case, and we will do the same just for getting a single coin. So let's remove the S here. And what do we need to change? Well, we also want to return a flow with a resource, but not with a list of coins, instead with a coin detail. We also want to emit the loading resource when we start making that API call. We want to get the single coin using repository get coin by ID. And well, which ID do we want to get here? We need to pass that. So we need to pass that ID as a parameter to this invoke function. Pass this here and call that toCoinDetail. So that is our UI object again. And here we then pass the coin, and the errors are basically the same. And that is already it for our two use cases that we have here in our app. Next up, we will implement the dependency injection setup with Dagger Hilt. So what's actually missing? We're missing dependency injection, we're missing the view models, our two view models for each screen, and then we're obviously missing the UI. So let's jump into our DI package and create our app module. In case you're not familiar with dependency injection, why do we even do this? The whole purpose of dependency injection is it helps us to make our dependencies replaceable. So a dependency is in the end just an object in our app. For example, a database instance, an API instance like we have here, whatever. There can be a lot, like a glide instance, coroutine dispatchers, all that are dependencies. And the thing we want to avoid is hard coding these dependencies into our objects. So what that means, let's say we open our getCoins use case, and we would do something like this, and we set this to a coin repository implementation, and here we pass our API that we could also create in here. This would be one of the worst things you could do. In the end, our use case would work because we have access to our repository. But what if you want to test this? This is not replaceable at all. You can't replace this with a test repository, with a fake coin repository, because you hardcode this in this class that it must be a coin repository implementation. And that is what we want to avoid. And to avoid that, we use dependency injection. So we inject the dependency from the outside, from the module we will create now. And in there we can easily swap these out. We can say, okay, for this test case, we want to use the fake coin repository. And for the production app, we use our coin repository implementation. So let's actually do that. So as I said, in the app module, we define the dependencies we have, and we tell Daggerhild, hey, this is how you can create these. We annotate this with module and install in. We install it in the singleton component. So that will just determine how long these dependencies will live. Installing it in the singleton component means these live as long as our application. So these are all singletons. Then we need to create functions here that create our dependencies. So we say add provides, because the function provides something, it provides a dependency. And we annotate it with singleton. So that will make sure that we only have a single instance of whatever the function returns. So don't confuse it with singleton component. That means all the dependencies in the module live as long as the application does. And this makes sure that there is only a single instance throughout the whole lifetime of our app. And we call this provide Paprika API, which returns an instance of our coin Paprika API. Let's return retrofit.builder. So we now just return, we tell Daggerhild, hey, this is how you can create such a coin Paprika API. We set the base URL to something we don't have yet. Let's open our constants and create that here. Base URL is https API coinpaprika.com, and don't forget the last slash. So we can assign that here, constants.base URL. We can say add converter factory, so we attach our JSON converter factory.create. We just make sure, hey, please use JSON to serialize and deserialize the JSON data. We call that build, oops, and create. So now we define the API interface that we want to create here, which is coin Paprika API ;class Java. And that is it for the API. Next up, we will have one more function that will provide our repository. So again, provides singleton function provide coin repository. And well, what do we need to create a coin repository? We need our API, coin Paprika API, and it will return a coin repository. So now we can just say we return a coin repository implementation with our given API. And because Daggerhild knows how to create our API, it will automatically pass that here as a parameter, so we can easily create the coin repository implementation. And here it's actually now fine to create that using this implementation class, because we are inside of our production app. If we would be in our test cases, in our test source set, we would simply create a fake version of our coin repository and have a test module. And in the test module, it would simply replace the dependency that we have here, and there we could then return the coin repository fake in that function. So that is what dependency injection is for and why it's so useful. It's one of the best patterns you can use for any type of software project. Next up, let's create an application class, which we also need for Daggerhild. That will be in our root package and called coin application. Just a normal class that will inherit from application. And this is basically just to give Daggerhild the information about our application. So Daggerhild also has access to the application context if we need that for our dependencies. So we simply say Hild Android app. And that is everything we really need to do here. We only also need to add this to our manifest. Let's open that. In the application tag, we say name coin application. And this is an issue because I copied stuff over here. We can simply replace this with cryptocurrency app, so without YouTube, and here as well. Because I just copied this over from my other project and this is how the app was named there. It doesn't matter here, just replace it. Close this, and now let's create our view models. So where are actually our view models located? So initially view models contained business logic, and they still technically do, but they don't belong to the domain layer. In the domain layer we only have the models and use cases and repository definitions and possibly other definitions. And the view models belong in the presentation layer because they are directly coupled to our views, to our composables. So here in our coin list screen, we actually now create a view model, which will be called coin list view model. Select file, and I actually made a live template here for a Hild view model, which you most likely don't have unless you saw the video from me about that. Just type this off. We create a view model here called coin list view model. And we inject dependencies here. If we inject dependencies in a view model, we need this special annotation as well. And we need one dependency, and guess what that is? That is not our repository now. We did that initially without clean architecture, but since we now have our use cases, we want to inject that instead. So get coins use case. Of type get coins use case. Cool. So now we have that. And with this get coins use case, we can easily now get the coins. So we don't have that in our repository anymore. So what we want to do, let's think about what do our view models now contain. Because, well, we moved most of our business logic from the view models to the use cases. So why do we even have our view models now? The main purpose of our view models is to just maintain our state. So we have view models because they, of course, keep the state, the UI state, even when we rotate the screen, when a configuration change happens, when we change the language, whatever. And that is still their job. They just now contain less business logic. They still contain business logic, but less than before. And for our single screen, I want to create one state object that contains all the information we actually need. So do we want to show progress bar? Is there an error? What is the coins list? And that's basically it. So let's create the object for that in our coins list package called coin list state, I would say, which will be a data class, and that contains a val is loading, which is a boolean and false initially. It contains our coins, which is a list of coin. So this one here from our model package, which is an empty list by default. And it contains a potential error, so a string, which is equal to an empty string by default. So we don't have any errors at all. And then in our view model, we can create a state that contains such a coin list state, which we will then expose to the composables. For that, I also have a live template, which is called ViewModel state, which creates a private and a public version of that. So that will just be called state, coin list state, and the initial value is just an empty coin list state with the default values. The reason why I choose to have a private and a public version of that is that we actually don't want to be able to modify the content of this state in our composables. So that is why we can only access this mutable state in the view model, and we expose this immutable state to our composables, just to make sure that only the view model touches this, because otherwise this would be not so good. Then it wouldn't be a separation of concerns anymore. Now we do want to have a function that actually calls our getCoins use case and provides the data, or rather puts the data inside of our state object to display that in our UI. So private function getCoins. And what happens in here? Well, we can simply call our getCoins use case like a function. You know, that is a class, but because we overrided the invoke function, if we remember, we have an operator function invoke. We override that operator function, and that allows us to call this use case like a function, and I just like this. So that now returns the flow that emits the resource values over time. So we want to call on each. So on each element that this flow emits, on each resource object, we want to now do something. I'll call this result, and we say when result is a success from our resource, we do this. If it is an error, we do this. And finally, if it is loading, we do this. Let's start with loading. In that case, we just want to assign a value to our state. We want to set it to a coin list state with the default values, but we set is loading to true. If we get an error, we set the state.value to coin list state error is equal to result.message. And if that's null, we say, let's do that here, an unexpected error occurred. Format that a bit. And finally, if there is a success case, we say state.value is coin list state, and we set the coins list to result.data, so our list of coins, and if that's null, just an empty list. So all that function does is it executes our use case and puts the result simply into our state object that we will have for our composables, to just have a very readable code. So we just see, okay, if it's loading, we do this in our UI, we show the progress bar. If there's an error, we do this. If it's successful, we display the list. Right now, nothing happens if we execute on each because it's a flow. We also need to launch that in a coroutine because flows are asynchronous. So we say launch in, and we launch it in the ViewModel scope. And then let's execute this function simply here in init. And just say get coins. It's really that easy. And that is everything we need to do now for our coin list view model. Let's copy this view model and paste it in our coin detail package, because now we are going to work on the coin detail view model. So coin detail view model. And well, we need to change some things here. First of all, the use case. We don't need the get coins use case anymore, but if we would need it, we could simply also inject it here. So that is how we can reuse use cases. But we need the get coin use case. We just want a single coin. And this one. Let's also copy our state here, our coin list state, and paste it in our coin detail package. Call it coin detail state. It will also contain is loading and error, but this will just be a single coin. Won't be a list of coins, instead just a coin detail object. And by default, just a coin detail object with default values. Oh no, we don't have default values here. So let's just make it nullable and say is equal to null. And then in here, instead of a coin list state in our coin detail view model, we have a coin detail state. Copy this, paste it here, 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 and here. replace this with coin is equal to result.data, and this with get coin use case. And this now takes a parameter, which is the coin ID. How do we get that in here? Well, this is where a super cool feature now comes into play. And that is using the so-called saved state handle. So I will write this here, and then I'll explain it. We have a private val saved state handle of type saved state handle. So the saved state handle is basically a bundle, and it contains information about the saved state. So we can use that to restore our app from process death, for example. And the cool thing is it will also contain the navigation parameters. So what we will do is, when we navigate here, when we click on Bitcoin, we will pass the ID of Bitcoin as a parameter to our detail screen. And in our detail screen, we will load that coin from that API with that ID. Because we pass that as a navigation parameter, that ID is contained in that saved instance state already, a saved state handle. And that's really cool, because now we don't really need to pass our parameter to anywhere. We can just access it in our view model and load the corresponding coin here. So we can simply rename this, pass in the coin ID here of type string, here as well, and in our init block we say saved state handle dot get, so we can now get a specific key. It is of type string, so our coin ID, and let's create a constant for that. Const val param coin ID is just coin ID, and then say constants that param coin ID. We check if it's not equal to null, give it the name of coin ID, and if it's not equal to null, we simply say get coin and pass our coin ID, and that will work. That is really, really cool, and we don't even need this here. So we can just leave it like that. Alright guys, now we actually have a state in our coin detail view model that will contain the corresponding data from our API when we visit the screen. And we have the same state, a different state, in our coin list view model that will also contain the data when it is actually available, or the error, or the loading status. So now all that's missing is our UI. So let's implement that next. So the first thing we're going to implement from our UI is a coin list item, which will be such an item here. So just a composable for that, and then we can create a list out of that very easily. So in our coin list package, components, so since that is just a composable that doesn't make up a single screen, it will be put in the components package, and we will call it coin list item, select file, create a composable called coin list item. And this needs two parameters. On the one hand, our nav controller to be able to navigate when we click on an item, or rather no, let's not pass the nav controller here. We will actually just have a function that, a lambda function that gets called when we click on it, and we can navigate one layer above. So instead we definitely need the coin to display data of type coin, and then we need on item click, which gives us this coin as a parameter. Okay, so we just have a row here. I won't explain all that UI stuff here in detail. I think if you watched this video you will know the basics of Compose, and if not, I have a playlist about that. So we'll just apply a modifier fill max width. We say clickable, in which we say on item click with our coin, and we give it a bit of padding, let's say 20 dp. Then we set the horizontal arrangement to space between, so just to make sure these two entries here, these texts are pushed to the sides of our item. And yeah, and here we just have two texts. The first one contains, first of all, the coin rank, then a dot, space, then we have the coin name, space, open parentheses, we have the coin symbol, and close the parentheses. So the coin symbol is, for example, BTC for Bitcoin. We can attach a style here from our theme, typography, and that will be body 1. And we actually want to set the overflow to ellipses. So if the text gets too long, we will just cut it off. And then let's copy this. No, let's not copy this. Let's create another text here. And this text will be, if the coin is active, it will be active, and else inactive. The color of this text will also be dependent on that. If the coin is active, we say material, actually not material theme, we just say color green, and else colored red. The font style will be italic, so yeah, it's just italic style, and the text align will be end. Let's set the style to body 2, so it's a bit smaller. And what's missing? A modifier is missing, that we actually align this vertically, align center vertically, and import that. Cool. That should be it for the coin list item. Let's go to the coin list package, create a coin list screen. Coin list screen, and that will now take the nav controller, and it will also take our coin list view model, and we can get an instance for that using hilt view model. And that will automatically just give us this ViewModel instance. It's very easy. So let's think about what do we actually have on that screen. Well, it looks like we just have our list, but we have a bit more. In the end, we just have a big box. And if it is actually successful, if it's a successful response, we show the list. If it is not, we show an error, just error text at the center of our screen. With a bit more setup, you could also show snack bars and stuff like that, of course, but I keep it simple. And of course also progress bar in the center of our screen, which we can see very, very shortly here. If we load something, it's very quick. So let's actually say we first want to get a reference to the state from the view model. View model state.value. And then we have a box. Modifier fill max size. Let's open that. We have a lazy column in which we display the list of items. So modifier is modifier dot fill max size as well. And in here we say items, and we import these items that give us a list here. So we can just pass our state.coins. So for each single coin, we can now map that to a composable, to our coin list item, pass the coin here, and on item click here. I will put that into separate lines. When we click on a coin, we want to, what do we want to do? We want to navigate. Nav controller, navigate to our route, which we don't have yet, of our second screen. So what I will do in, let's do it in our presentation package. I'll create a screen class, a sealed class called screen. And this just helps us to deal with routes. So just a route in the constructor. So that is how we deal with navigation in Jetpack Compose. And in here we have an object for our coin list screen. Inherits from screen, and we pass coin list and a coin detail screen. Coin detail, let's actually call it screen. And then we can actually pass that here. So we want to navigate to screen, coin, detail screen.route, and because it takes a parameter, we need to append something here, which is a slash and the coin ID. So let's just say coin.id. This is basically just like a URL. So we just append a path parameter here to have access to the coin that we actually want to load in our coin detail screen. Then below this lazy column, I want to check if the state, that error, is not blank. So if it actually contains an error, then we want to show a text. This text will contain the error. And the color will be material theme dot colors dot error, text align center, and let's attach a modifier of modifier dot fill max width, padding of, let's say, 20 dp and only horizontally, and we say align in the center. That should do it, like this. So that's it for the error that we display. Let's also do the progress bar. So if the state is loading, and you see just how readable that now is, having such a state object with these single values in here. If it's loading, we say circular progress indicator. And we make sure to align this in our center of the box. And yeah, that's already it for the screen. So we can actually copy this coin list screen. Oh, that's not copied yet. We first want to write some components for our coin detail screen. First of all, I want to write a coin tag, so composable for such a tag, and an item for a team member. So let's start with a tag, new coin tag, which is a file, composable coin tag. What does that take? It takes the tag in form of a string, and that's already it. Here we can just create a box, set the modifier to modifier, let's do it like this. Modifier dot border, we're gonna have a border here with 1 dp. Color is material theme colors primary, and the shape is a rounded corner shape of a very large dp amount. And then we say we have like 10 dp of padding. And in that box we do have a text that says just our tag. Then we have a color for that text, which is our primary color. We say text align center, like this, and we say we have the style material theme dot typography dot body 2. So that's it for the coin tag. Let's create a component here for the team list item. Team list item, which will contain the team member and an optional modifier here. So we will essentially just have a column here. What we're going to do is just such an item here, just two texts on top of each other basically. The column will have our modifier as a parameter. It will have vertical arrangement center. And then we have two texts in here. This one will be teammember.name. The style will be material theme typography H4. Have a little bit of space in between these two texts. Let's say 40p. Copy this text, paste it down below. This will show the position, so if it's a founder, blockchain developer, or whatever. Replace the style with body 2, and I want to have a font style of italic again. Cool, so that is it for the team list item. Now we can copy the coin list screen. Let's just do it and paste it in coin detail. Call it coin detail screen, of course. And now adjust this. This will now, of course, take the coin detail view model. The nav controller, I think, isn't needed because we don't really navigate to anywhere from the screen. And to get back, we can press our back button. We still get the state here. And now let's think about it. We have some fixed items here, so it's not really a list of one type of item, but it should still be scrollable in case it's a long list here of team members or whatever. Yeah, we will have a lazy column here, definitely. So instead of that box, we say state.coin, which is a nullable coin detail element. We want to make sure that it is actually not null. Get the information of that coin here. Put this in here, so our lazy column. And here, let's delete that for now. First of all, let's build this top section here. So this text and this active thing. We can just use a single item block here to do that. It's a row. We did something similar here already, but we want to have a larger text. Modifier fill max width and horizontal arrangement of space between. And I also want to give our lazy column a bit of padding. So we can say padding, content padding is padding values of 20 dp. And then let's go inside of our row. We essentially have the same type of text again as we had on the list. So coin.rank dot space coin.name space open parentheses coin dot is not is active coin dot symbol and close parentheses. This time it's actually larger, so let's set the style to material theme H2. And I'll attach a modifier, actually a weight, so this won't really overlap our active text, and the weight will be 8f. Then let's have the active text, which is if is coin active. It says active and else inactive. Color if coin is active, color.green, else color.red, font style italic again, text align will be end, and a modifier to center this vertically and apply some weight. Align center vertically, nope, not this one, this one. Import and attach a weight of 2f here. So that will just be the top section here, this Bitcoin text and this active. Now we have a little bit of space and the description and another space. So let's have another of these item blocks. Well, I think we can actually just put everything inside of a single item block. Let's do that. So that is automatically treated like a column here. So we have a row and below that a bit of space. Let's say height is 15 dp. So now we have our description text. Text is coin description. Style, material, theme, typography, body 2. Oops, same space again. Then let's have a text for the tags. So text is equal to tags. Let's set the style to material theme. Typography H3 I will choose here. Another spacer. Then I will use something called a flow row, which comes from a dependency I included. This one here from the Compose library. So a flow row is basically a row that will wrap the elements if they exceed the bounds. So all of our tags will be put inside of this row next to each other, but if one tag gets too long to fit on our screen, it will just be put into the next line. That is what the flow row does. And that's not contained in Compose by default, so we need a library. I want to set the main axis spacing to 10 dp and the cross axis spacing to 10 dp, so just the spacing, so how much space we have between items on the main axis and cross axis. And a modifier of modifier filmmax width. And in here we can then put all of our tags we actually have. So coin.tags for each tag. And for each tag we just have a coin tag and passing that tag as a value. Then let's have another spacer below this flow row. And what comes next? The team members text. So we can basically just copy this tags text because it's the same styling. Call this team members. Have another spacer. And now the list for the team members won't be put in here because that could be multiple items. So we go below this items block and have a real items block with multiple ones. Import the one with a list again. And for each team member a coin actually has. So let's say team member. And yeah, perfect. For each of these we actually just have a team list item where we pass the team member. And we're going to pass a modifier of modifier fill max width and padding 10 dp. And then I will rearrange that. And below each team list item I'll just put a divider. So we have these lines here. And down here we have the same logic for our error and our loading bar. So that is actually everything for this coin detail screen. Now the very last thing we need to do is to set up the navigation, which is very quick. So where do we put this? I will create a components package in the presentation package. So that will contain components that all of our screens could possibly share. I'll put in navigation here. Let's not do it. Let's just put in the direction, the navigation directly in main activity. So here in our surface we have our nav controller, which is remember nav controller. And then we have navigation, actually not navigation, nav host. Pass in the nav controller, and as a second parameter the start destination, which is simply our list screen. Screen coin list screen dot route. We open this up, and yeah. If you're new to this, for each single screen we basically have such a composable block. We define the route, which is what is that? The first route is screen coin list screen dot route. In here we then just put the composable that the screen represents, which is coin list screen. That is already it. Let's copy this for the other screen. Replace it with coin detail screen. Coin detail screen. Didn't I rename this? No, I didn't. So go to coin detail screen.kt. Rename this to coin detail screen. And then we can say coin detail screen here. And we import this coin list screen again, this time from our presentation coin list package. And this will actually also take the nav controller here. This screen needs a parameter and a navigation argument, which is the coin ID. So we need to define that here. We simply append a slash, curly braces, and in that the name of that parameter. So write it exactly as I do here. And one more error is an import error. We can simply press Ctrl-Alt-O to fix that. So if I'm not wrong, that should be everything. No, not yet. We need to annotate this activity with Android entry point, which just allows Dagger Hill to inject dependencies into this activity or in sub-composables, which we need for the view model. And I think that should now be it for our app. No, one thing I remember is we need internet permission. Let's go to manifest before I forget this. Uses permission internet for retrofit. Yeah, I would say we just launch this. Try it out. I will launch it on my other device because for some reason I can't enable airplane mode here on this device. I mean I can, but it still always uses Wi-Fi, and for some reason I can't turn off Wi-Fi here. So I will launch my other device and I'll see you back when that is launched and hopefully successfully built. And also, after we try this out, if everything works, I will go through all of what we did again. Just a quick recap, so you just don't forget, or in case you don't know what I did at some point. I will just explain the rough structure again and why we do things like we do. But yeah, then that is pretty much it. And I'm back. We actually get an error here. Not enough information to infer type variable t. It seems like it can't really recognize that in our code. But what we can do is we need to specify the type here of that resource. So coin detail. I think this should be enough if we put this here. It says we don't need this, but I think we actually do. And it can also be that we need to do this in our other use case. Yeah, we also get this in our other use case. So in our get coins use case, let's do list of coin here. And let's copy this. Here, here, and here. So it's just not really sure about the types here. But then this should actually be fine. Couldn't reach server, check internet connection, which... This is unexpected because we do have internet connection. Couldn't reach server. Maybe the base URL is wrong. What did I type here? API coin paprika.com. Good question. What is the issue here? Let's relaunch that. It'll probably give us the same error. I will look into this and then I will tell you. Okay, so I looked into it. I added a logging interceptor here to retrofit, and you see the request failed because of socket exception, eperm. That is a common exception. I don't know why it happens. It's very easy to fix. We just need to uninstall and reinstall our application, and then from then on it will work. So that just sometimes happens with retrofit when it doesn't work and then we change something, and then this can be the reason. So all we need to do is go to our emulator, uninstall this app, and reinstall it and launch it, and then that should work. So let's see. There's our loading bar, you can see, and now we have the list of coins here in our app. It's a little bit laggy in the emulator, but on a real device it's not. And now it's not laggy. Cool. So what happens if we click on Bitcoin? Then we get the data of Bitcoin. So it seems like everything is working. Let's choose maybe a longer coin. This one here, you can see then it's simply wrapped, so it doesn't overlap the active text. Cool. Cool, cool, cool. So I hope you really enjoyed this. I will now give you a recap of what we actually did here. And by the way, let's also test the error case. So we already saw that with the error here, but I turned on airplane mode, launching this, and yeah, this now gives us the error, check your internet connection, couldn't reach server. So that works. Perfect, perfect, perfect. So as a recap, clean architecture consists of presentation layer that contains the UI and view models. The domain layer contains the business logic in form of use cases and model classes and interface definitions. And we have the data layer, which contains the repository implementations and the actual kind of data objects like a database, like an API, data transfer objects. That could also be something like a model that you save in your DB. You would also put that in the data package. And yeah, then we have a common package with just shared resources here for our whole app. DI package for modules. We have these DTOs, data transfer objects, which are the objects we directly get from our API. So directly mapped from the response, the JSON response, to a data class. We then have a mapper function to map these two objects we actually show in our UI. So these are quite huge. We don't want to have that in our UI as an object. Instead, we only want to have a lighter version of that, the coin detail one. And for that, we simply map that to such a coin detail object. Then here in our use cases, we override the invoke function, so we can execute it like a function. In that case, it now returns a flow. It doesn't always need to return a flow. It can also do something else. So you could also do the flow stuff in the repository. So then you would just call a repository function in that use case. But it could also be, let's say you have a login use case, then you can do the validation in here. So you check if the fields are not empty, you check if the password contains like at least 8 characters and special characters and stuff like that. This stuff would be done in a use case. And then, yeah, there's not much more. We just put in our UI in the presentation package. In our view models, we just call the corresponding use cases here that we inject in the constructor, check what kind of resource that is, and depending on that, we update our state that will then be exposed to the composables to display that. And that is it for this course. I hope you really enjoyed this. Please, please, please let me know that below in the comments if this helped you. That would make me happy, and you know, that pushed this video. This took quite a lot of work to make this, easily 1 work day or even 2 work days to make this app and this video here. So that would be really appreciated if you could give this a like and comment and even share this with your Android friends. And because you actually watched this till the end, that's quite a good amount of support you give me, because the watch time is really it really decides about the success of a video. I will give you an exclusive 10% discount for my more advanced premium courses on my website. So do check these out. The discount code is clean_architecture. With that, you will get permanent 10% off. I don't publish this discount anywhere else. So yeah, because you're serious with Android development, you can also get my paid courses cheaper, where you can also learn things like these. And also, of course, if you want to learn more advanced things for free, then just subscribe to my newsletter. As I said in the beginning, you will just get regular text content about Android, about Kotlin, development, and architecture. So really don't miss out on that. And apart from that, thanks for watching. I wish you an excellent day, and I see you in the next video again. Bye bye.